The launcher rose, the booster lit, and a weapon that had refused to fly for so long finally blasted into the sky. That weapon was a hypersonic missile. In June 2022, a full test of a similar weapon out of Hawaii failed after ignition. The glide body never got the chance to do its job. Later that year, another test was delayed while engineers tried to understand what went wrong. In early 2023, a planned flight from Cape Canaveral was scrubbed at the last moment because of a battery problem. In September of that same year, another countdown was stopped again during final checks. Inside the Pentagon and on Capitol Hill, people knew that China and Russia were already flying their own hypersonic weapons more often, and patience was running out. When the December launch team talked about what they had just done, they used a dry phrase that hides how big the moment was. They called it an all-up-round test. In plain language, that means they were finally testing the whole weapon as one piece, from launch truck to booster to glide body, instead of firing only parts in lab trials. Earlier that year, in June 2024, a full version of the same missile family flew from the Pacific Missile Range facility in Hawaii. That test showed that the glide body and the booster could work together the way they were supposed to, but the December shot in Florida went a step further. It was the first time the real battery operations center, the real trailer launcher, and the full missile were all linked together and fired as one system, exactly the way a real unit would use it. The Army's official name for this weapon is Long-Range Hypersonic Weapon, but soldiers use a much shorter nickname, Dark Eagle. It is a ground-launched missile that is meant to reach far beyond normal artillery or rockets, and to do it much faster than older systems. Here's how it works. A large rocket lifts a special glide body up into the higher parts of the atmosphere. After that push, the rocket drops away and the glide body takes over, racing toward its target at extreme speed. Dark Eagle has a big two-stage solid-fuel booster at the back. You can think of it like two very powerful bottle rockets stacked together, built to shove the glide body up to speed and altitude. On the front is the common hypersonic glide body, a wedge-shaped craft that stays inside a protective cover during launch. The word hypersonic can sound like a sales pitch, but here it has a simple, real meaning. It means flying faster than 5 times the speed of sound. In practice, that is well above 3,800 miles per hour, depending on height and air. A normal ballistic missile can also get very fast, but it follows a basic, predictable arc, like a slow-motion throw. A glide body like the one on Dark Eagle does something different. It rides the thin air high above normal jet routes, then uses its shape and small control surfaces to bank and turn. It can drop lower, swing to the side, and force enemy radars and interceptors to guess where it will go next. That mix of speed, long distance, and side-to-side movement is what makes this kind of weapon so hard to stop. Range is the other big part. The reach of Dark Eagle is around 1,725 miles. To picture that distance, think about the stretch from New York to Denver. A launcher parked at one end could hit a target near the other end without moving an inch. A rocket that can travel that far at hypersonic speed does not just cross a border, it crosses whole regions in only a few minutes. On the ground, Dark Eagle does not sit out on a launch pad by itself. It stays inside a sealed launch canister that sits on a heavy trailer pulled by a military truck. An Army battery built around this weapon uses 4 of those launch trucks. Each truck carries 2 canisters, giving the unit a total of 8 missiles ready to go. Beside them is the Battery Operations Center, a boxy command truck filled with radios, screens, and crew. That small group of vehicles is all the Army needs to bring hypersonic firepower into a new region. The trucks can spread out along a road or around a small base, power up, take in target data, fire, and then move again before an enemy can locate them. Artillery officers call this shoot and scoot, and it is a basic survival tactic in a world filled with sensors and long-range enemy fire. The first real soldiers to train on Dark Eagle equipment belong to the 1st Multi-Domain Task Force, a special Army group that links long-range fires, cyber tools, space sensors, and air defense. They are based at Joint Base Lewis McChord in Washington State, and they have already practiced moving their launchers to Cape Canaveral for test work. Army plans given to Congress say the goal is to have the first Dark Eagle battery fully fielded by the end of fiscal year 2025, with more batteries coming later in the decade. The same glide body used on Dark Eagle is also heading to sea. The Navy calls its version Conventional Prompt Strike. The idea is almost the same. A large booster throws the common glide body onto a high-speed path, but this time the rocket shoots out of a launch tube on a ship or submarine instead of from a truck on land. On May 2nd, 2025, the Pentagon announced the first full end-to-end test of this sea-based version from Cape Canaveral. The missile did not fire its main motor while still inside the launcher. Instead, a cold gas system pushed it out of the tube first, almost like a giant shotgun shell being popped out. Only after it cleared the launcher did the booster ignite. That cold start matters because it is the only safe way for the weapon to leave a ship's vertical launch cell without burning the ship itself. Navy plans say the first ships to carry this hypersonic setup will be the stealthy Zumwalt-class destroyers. Those ships have already gone into dry dock to remove some of their guns and install larger missile tubes. After that, later versions of the Virginia-class attack submarines are expected to carry the same weapon in new sections filled with launch cells. Public budget and oversight reports show the Navy wants the first surface ship armed with this system before the end of the decade, and the first submarines in the early years of the next decade. For a fleet that has relied for so long on cruise missiles that fly at subsonic speed, this is a major step forward. It changes how fast and how far a ship can strike without needing aircraft to reach the target. There is a reason the Pentagon gets so tense before each test. Hypersonic missiles are not cheap to experiment with. One Dark Eagle missile costs tens of millions of dollars, with one estimate putting a single round at about $41 million. The overall hypersonic budget request also climbed to almost $7 billion in a recent year before dropping again.
This is the rocket motor that launches it out of the vertical launch system. So it is what propels it out. So when you see the footage of a missile coming out of a ship.
As programs shifted, when a test fails, that money is simply gone. When a test succeeds, it clears the path for the next step, moving from trial hardware to real missiles in the hands of the units that will use them. All of this work is aimed at a clear purpose. The Army says Dark Eagle is meant to help punch holes in an enemy's anti-access and area denial shield. That means it is built to take out the most important sites deep inside a heavily defended zone, and to do it fast. Those targets include hardened command bunkers where leaders hide, large radar sites that watch the skies and seas, long runways and fuel tanks at major air bases, and big warships that act as floating airfields or missile platforms.
In the minds of most military leaders in the United States, if China and Russia have hypersonics, the US should too.
How Dark Eagle puts carriers in danger. For most of the last century, the biggest warships on Earth lived off one simple advantage. They could stay far from danger, sit in deep water, and still send jets hundreds of miles inland. An aircraft carrier could cruise well beyond the reach of most guns and short-range missiles, launch one wave of planes after another, and then turn away before anyone could reach it. For a long time, distance was its most reliable armor. That comfort started to fade once China began filling its coastline with long-range missiles. Rocket units no longer had to chase carriers across the ocean. They could stay on home soil and still reach far into the Western Pacific. Over the years, newer missile models pushed their reach from a few hundred miles to more than 1,000 miles, and then out toward roughly 2,000 to 2,500 miles. That was enough to threaten major ships and bases deep in the open Pacific. Huge stretches of water that once felt safe slowly turned into high-risk zones for any large ship sailing through them. Planners often show those danger zones as simple circles on a map. Put the point of a compass on the Chinese coast and draw a circle about 1,000 miles wide. It covers most of the sea between the mainland and the first island chain that runs past Japan, Taiwan, and the Philippines. Stretch that circle to about 2,000 or 2,500 miles, and it begins to touch places like Guam and the northern tip of Australia. Studies from American and Allied research groups use these rings to show how far Chinese conventional missiles can already reach toward key air bases, ports, and shipping routes in the region. Now drop a modern carrier group into that picture. In the middle sits one giant carrier, surrounded by destroyers and cruisers with jets overhead. To put short-range fighters over a target, the carrier has to move closer. But the closer it sails, the deeper it moves into those missile rings. If it stays farther back to be safer, the jets need more fuel and more time just to reach the edge of the fight. Even before hypersonic weapons appeared, navies were already arguing about how close these ships could safely go inside those danger zones. The new hypersonic systems push that problem much further. The land-based weapon the Army is building and the sea-based version the Navy is adding to ships and submarines do not just add one more missile. They stretch the American side of the map the same way Chinese missiles have already stretched theirs. Because Dark Eagle can reach roughly 1,700 miles or more, a battery placed on an allied island or a friendly coastline can strike targets deep inside the Western Pacific without moving at all. Once you start placing that kind of reach on the real map, things shift fast. A unit in Japan can cover much of the East China Sea and large parts of the South China Sea. A unit on Guam can look back toward East Asia and forward across the Philippine Sea. A battery in northern Australia can reach into the wider Indo-Pacific from the south. These American range rings overlap with the same waters already covered by Chinese long-range missiles. When both sides can reach deep into those same spaces, the old idea of having any truly safe zone begins to disappear. Sea-based launchers add even more angles. A Virginia-class attack submarine fitted with the Navy's hypersonic strike package can move quietly through deep water, slide into a launch position, and fire without warning. A Zumwalt-class destroyer armed with the same weapon can sit in the Philippine Sea or the Indian Ocean and hold both ships and coastal targets at risk from long range. Large surface ships now have to worry not just about what sits on one enemy coastline, but about long-range weapons that might come from many directions at once. Speed is what makes these new weapons so hard to live with. By the time ship sensors are sure that a strange track on the screen is a real attack and not a test, there may only be a few minutes left to react. Studies from major defense institutes warn that this shrinking warning time is one of the biggest shocks hypersonic weapons bring for navies used to slower, more predictable threats. Chinese researchers added to that fear with a computer war game that made headlines in regional media. In their simulation, they did not fire just one hypersonic anti-ship missile at an American carrier group. They launched 24 missiles in a single wave. The escort ships in the model burned through their interceptors and decoys trying to thin out the attack and still lost the carrier. It was only a simulation, not a real battle, but experts in many countries noted that it lines up with how real planners now think. The danger is not one perfect shot. It is a heavy volley of very fast weapons arriving almost at the same time. If that is the kind of attack a carrier might face, the simplest way to keep it safe is to push it farther back. Moving the ship 100 or 200 extra miles from the center of trouble can pull it out of the worst part of the missile threat, at least for a while. But every mile you add for safety is a mile you take away from your jets. The planes have to fly longer just to reach their patrol area. They burn more fuel and depend heavily on mid-air refueling. They spend less time over the target and more time commuting back and forth between the carrier and the edge of the missile zone. This trade-off eats into the carrier's biggest advantage. A floating airbase was powerful because it could move close to the fight, stay on station for days or weeks, and keep launching planes even when land bases were damaged or too far away. Once the ship has to stay much farther out to survive, that steady rhythm breaks. The carrier still matters, but it can no longer dominate a contested sea the way it once did, back when only a few countries had long-range strike weapons. China's own Navy adds another twist. It is no longer just a land-based missile force watching American ships from shore. Over the last decade, it has brought large carriers into service and pushed them farther from home. The Liaoning and the Shandong have both carried out drills in the Philippine Sea and beyond what planners call the second island chain, east of Japan and Guam. At the same time, the newer Fujian carrier, fitted with electromagnetic catapults that can launch heavier, more capable jets, has started sea trials and early flight tests that point toward a larger and more advanced air wing in the coming years. Those big Chinese carriers now live under the same kind of threat that worries American carrier captains. If American or Allied forces place long-range hypersonic units in Japan, Guam, or Northern Australia, or send submarines and surface ships forward with the Navy's hypersonic weapon, those Chinese carriers sit inside someone else's danger rings. They are exactly the type of high-value, slow-moving targets that hypersonic systems are built to.